question is, what is the density of monic polynomials, integer polynomials, such that the discriminant of that polynomial is square-free? Okay, so we're trying to understand the square-free. What is the density of square-free values taken by the discriminant polynomial, right, of degree n monic? In particular, is the density even positive? Okay, that's also was not known. Yes, this is a classical question. The reason it's arisen in number theory, the question of whether a discriminant is square-free, is that often one constructs number fields by taking q adjoint x and modding out by a monic polynomial. And one is interested in constructing the ring of integers in that number field. And it turns out that you can do that very easily if the discriminant of f is square-free. So when we take algebraic number theory, we often consider number fields that are defined as q bracket x mod f of x. So we'll call that k sub f. And then one's interested in constructing the ring of integers in kf. And if f has square-free discriminant, then the ring of integers is just given by z bracket x mod f of x. So this is what we always want to do in algebraic number theory. When we're given a polynomial f of x, we hope that the ring of integers is z bracket x mod f of x. And that will definitely happen if the discriminant of f of x is square-free. The reason being that if it wasn't maximal, then if you went to the maximal order, a square factor would go away from the discriminant. But if the discriminant was square-free, that can't happen. So that's something very useful about monic polynomials of square-free discriminant, is that you immediately know the ring of integers inside q bracket x mod f of x. It's just z bracket x mod f. So if there are lots of such polynomials around, then you have the easy recipe for the ring of integers in many number fields. And moreover, so not only do we know the ring of integers, but in that case, the ring of integers is monogenic. It's just generated by one element, and it has square-free discriminant. So those two properties are also often useful when you have a number field. But this raises a more general question, which is, when you take integer monic polynomials and order them by height, what is the probability that z bracket x mod f of x does actually give the ring of integers inside q bracket x mod f of x? So the discriminant being square-free is this